Today we're going to be looking at programming languages. Computers aren't human. They don't follow instructions in quite the way we do by interpreting what language gives us and understanding the meaning of what someone wants to say. Instead, computers follow the instructions that are encoded in binary. These binary codes are usually represented using hexadecimal numbers because 2 hexadecimal digits makes up 1 byte. And what you're looking at on the screen at the moment is the hexadecimal codes in the middle column, which form the instructions that make up a very small program. We divide programs into 2 broad categories. There are interpreted languages. Many of you will be familiar with Scratch. Scratch is an interpreted language. It's a visual language because it implements a very nice drag and drop interface for the programming elements. But interpreted languages are not necessarily visual. I'm just using this one now so that you can see what happens when we run these. And in an interpreted language, the code that you are running is executed line by line. So this code has a loop which is going to carry on forever. It's going to move the little cat by 10 pixels and bounce if it hits the edge. But we can change this code while it's running. We can speed up the cat just by dragging out the weight. I can take a rotate and drop that in here, and the code changes and the cat starts moving in a different way because this is interpreted in real time. Any change I make is implemented immediately, and the programming isn't rebuilt to be able to run it. It's executed line by line. Line by line also has one other important implication. I cannot take this program that I've got on the screen and run it without the Scratch environment as a whole. For comparison, let's have a look at a Delphi Hello World application. Delphi is a compiled language. When I run the program, what happens in the background is the language is compiled into a machine code variant, and the machine code variant then runs, and I end up with this very simple little Hello World type program. That's what we have in the screen at the moment, with the hexadecimal codes that actually represent the instructions showing in the central columns. And the nice thing about an actual compiled program is we can close the Delphi environment. We don't need that. Don't even need to save it. And we can go to the actual program. There is the demo program that I created, and I can run that. And without the Delphi environment being available, it will still work. So these are your 2 broad categories. We've got interpreted languages and we've got compiled languages. Inside that range of categories, there are still a number of options. For example, this is assembly language. Assembly language is a direct human-readable interpretation of the actual machine code which the computer would execute. And you can program directly in assembly language, as has been done here. It is slow and a painful process. If machine code is regarded as the first generation of computer language, then assembly language would be the second generation, where we have tried to make things just that little bit intelligible to humans. Third generation languages include things like Delphi and C and Java, which is based on C. They provide a more abstract way of developing our program logic because we do not have to worry about the fundamental hardware that the computer's using anymore. There are also 4th generation and 5th generation and even 6th generation languages as we move further and further away from the hardware and hopefully make it easier and easier for non-technically trained people to use. So SQL, for example, would be an example of a 4th generation language. And the tools that our new large language models provide bring increasing abstraction and the likelihood of 6th and 7th generation languages becoming much more common. So where in all of this does Java fit in? Well, Java is a slightly different kettle of fish. Java compiles code to an intermediary stage. The Java compiler compiles into Java bytecode, and the Java bytecode is then interpreted by a Java virtual machine. So it's an actual compiled language, but it's a compiled language that runs on a virtual machine. The nice thing about that is we can copy that virtual machine to any different system that it has been built for. You have a virtual machine that is built for an Apple, or you have a Java virtual machine built for a Windows computer, and inside that virtual machine, any Java program can run. Let's have a look at how one would go about making a Java program. The easy way is to use an IDE, such as this one. We have IntelliJ here, we have NetBeans. Both of these are IDEs which are designed, among other things, for working with Java. Eclipse is a very popular IDE for Java as well. Visual Studio Code, many of your textbooks will start off using JGrasp as a simplified IDE and very effective for the purpose. But you don't need an IDE at all. Even a simple text editor will do. So I'm going to start up with Notepad++. I'm going to use that rather than the simplest text editor, which in Windows is Notepad, just because I can enable syntax highlighting for Java. It makes it look a little bit prettier and easier to see what's going on. And we can start with the absolute basics of a Java program. I'm going to create a class, public, and we'll call this demo because we're going to be demonstrating. Java has the requirement that the file name must match the class name, so I'm also going to save this as demo. Let's save, and I'm going to call this file demo, demo.java. Every Java program needs to have a main method. When you're starting off, this is a lot to remember. But unfortunately, when you're starting off, all of this is required by the Java language to enable your program to run. You need to define your class with the keywords public, class, and then the name of the class. You need to define the main method, which is what the Java runtime environment is going to look for when it tries to run your program. And that will also have to be defined with the keywords public and static. The term void refers to what values this returns to the operating system. So that could be one of void or int or one of the other types, but just stick with void for now. And the keyword main, which is the name of the method. This one has to be main. Programs can be started with arguments. So the command line arguments would be placed into these variables here. These terms will, I hope, become clear to you as the course progresses. But in the time being, please remember that all your programs will need this wrapper around your actual code, which will go in between these braces. The braces define blocks of code, and every opening brace is going to need a closing brace. And round braces have different meaning to the square braces and are different to the curly braces. At this point, I would like to apologize for anyone just starting off on behalf of all the Java programmers of the world. There's an awful lot to remember before you can even begin. But having got this far, let's begin. I'm going to display a simple message on the screen. In Java, everything is done using classes, and we can use the system class to manage console input and output. This is a simple text-based application, so it's running inside the system console. So we're going to use system.out to send a message to the system console. Print. And the ln over here is short for line. Java is a case-sensitive language, so where there's a capital letter, you need a capital letter. Where there's small letters, you need small letters. Strings are wrapped in double inverted commas. There we have it. We have two lines. The /n is an escape character that means go to a new line. And we save the program. This is the source code for my program. To be able to run this, I'm going to have to compile it. Remember, Java is a compiled language. So here you can see inside this folder the file that we've created, demo.java. It cannot run in its current form because this is just a text file. We need to compile this into Java bytecode. Changing to my command prompt, you get directory listing, and there is that same text file. We're going to execute the command Java C, that's short for Java compiler, and we're going to compile my demo program, demo.java, and it's going to create a Java class. You will see here we have demo.class. This is the output from the Java compiler. And that is the binary version of the program. This is the Java runtime environment machine code that would be executed by the Java runtime engine. So let's fire it up. We're going to use Java, and we're going to tell it to execute the demo program. There it is. Hi there, welcome to the Java club, complete with my capital letter typo in Java. And it's that simple. We can make our program and we can compile the code. You don't even need the fancy IDE. What the IDE provides you is several shortcuts that will help you with your code. When you start a program for the first time, you'll get a dummy application, so you don't have to remember about typing the boilerplate that goes around the outside of your code. And it will help you out as you go along by giving you hints, such as here the completion for the word system is system. And what possible continuations do I have? Oh, I have system.out. What methods are? Oh, I have printline. I can use that. IDEs are very helpful, but just as you're starting out, I do recommend that you start off in the simplest forms. Use the simple text editor or an editor like JGrasp. Get used to actually typing this stuff so that you get to know what it is. It also provides some interesting little automatic completions. So inside the IDE, SOUT with a tab will complete to system out print line. It makes it a bit faster to type. And commands are executed one at a time. Inside the environment, I can run my program and it will be displayed in a terminal that forms part of the IDE environment. Okay, don't have to worry about saving that. So there you have it, the simplest form of programming in Java. Write your code and you can run the Java compiler even without an IDE. The IDE makes it easier, and that is one of the reasons that we use them. But you don't need one. All right, I hope you find that useful. See you next time.